by 2 plus cos theta minus theta. Am I right? So what is the given interval? Theta is belongs to closed interval 0 to pi by 2. Closed interval. Okay. We have to prove that it is clearly increasing. Fine. First. So now here let us take this is equation 1. Here differentiate with respect to theta or x with respect to theta. So here dy by d theta is equal to, so what shall we do here? U by v rule. Since we know that d of u by v is equal to vu dash minus uv dash by v square. So what is u here? This is u, this is v. So vu dash 2 plus cos theta into 4 sin theta is 4 cos theta minus 4 sin theta into v dash. V dash means 2 plus cos theta derivatives minus sin theta. All divided by 2 plus cos theta the whole square. So minus theta is there. Minus theta derivative is 1. Minus 1. Theta derivative is 1. Now, so I don't want to take LCM. 2 plus cos theta whole square alone you can write. Now your multiplier 8 cos theta minus plus 4 cos square theta minus into minus plus 4 sin square theta minus 1. Yes. Yeah. So this is equal to 8 cos theta. Yes, 25 take 4 common. 4 common, cos square theta plus sin square theta becomes 1. So shall I write simply 4? 2 plus cos theta the whole square minus 1. This is dy by d theta, or else we can written as f dash of theta. Okay. So this dy by theta we have to equating to 0. So what is the first step? We have to calculate the first derivative, nothing but differentiate once. So after differentiating, we have to equating to 0. Now f dash of theta, that is dy by d theta, we have to equating to 0. So dy by theta means 8 cos theta plus 4 by 2 plus cos theta whole square minus 1 is equal to 0. Minus 1 is equal to 0. So when I take minus 1 right side, shall I write minus 1 becomes plus 1? Shall I write equal to 1? Yes? Yeah, you have to write. Now you have to cross multiply. So 8 cos theta plus 4 is equal to 2 plus cos theta the whole square. So write this 2 plus cos theta the whole square, you can square. So 4 plus 4 cos theta plus cos square theta, we are going to get a plus b whole square formula you can apply. So when I apply a plus b whole square, a square plus 2ab plus b square. So take all the values left side, so which implies left side is 8 cos theta, or else this 8 cos theta plus 4 you can take it right side. Okay, if I take right side, already right side cos square theta is there, plus 4 cos theta is there, plus 4 minus 8 cos theta minus 4 is equal to 0. So 4 get cancelled here, which implies cos square theta minus 4 cos theta is equal to 0. So what I have done here, I differentiated with respect to theta. After that, derivative I equating to 0. So now we are going to get the critical points. To find the critical values, you have to equating to 0. When I equating to 0, So I'm getting like this. Now, is there any common? Yes, cos theta is common. When I take cos theta minus 4 is equal to 0, which implies cos theta is equal to 0, cos theta minus 4 is equal to 0, right? So here cos theta is equal to 0 means theta can be written as, shall I write pi by 2? And here cos theta is equal to 4. Cos theta minus 4 is equal to 0 means cos theta is equal to 4. Then student, tell me what about this? Yeah. Is it possible cos theta is equal to 4? What is the cos theta maximum value and minimum value? What is the range? Minus 1 to 1. But is 4 is belongs to minus 1 to 1? No. So 4 does not belongs to minus 1 comma 1. So it is not possible actually. Okay. Not possible. Only cos theta is equal to pi by 2. Pi by 2 means C, student. So before this, you must know the general solutions of sin theta, cos theta, tan theta. You must be know that. Okay. Do you know what is sin theta, cos theta? General solutions. Like already you studied in class 11th and trigonometric equations. In that already you studied. Once again, I'm going to write sin x is equal to sin y. X is equal to n pi plus minus 1 whole to the power of n into y. Okay, next cos x is equal to cos y. So x is equal to, which implies the general solution x is equal to 2 n pi plus or minus y. And coming to tan x is equal to tan y, which implies x is equal to, yes students, n pi plus y, n pi plus y. So you should remember these three general solution. Sine. So if they ask cosecant, then the general solution of sine becomes the general solution of cosecant. It's reciprocal only, no? Okay. In the same way, secant general solution is given by cos. Cot general solution is given by tan. Okay. Right. So here they given clearly interval. What is the interval they given here? 0 to pi by 2. We have to prove that 0 to pi by 2. So see students, here now theta is equal to pi by 2. We got it here. Theta is equal to pi by 2. So we can take the real line here. So what is the real line, Amira? What is the given interval in the question? 0 to pi by 2. Am I right? 0 to pi by 2. Okay. Here also I'm going to take 0 to pi by 2. Close interval. Zero to pi by 2. So in this 0 to pi by 2, what is the theta value we got it here? From this cos theta, cos get cancelled, theta is equal to pi by 2 alone. So actually general solution is 2n pi plus or minus pi by 2. 2n pi plus or minus pi by 2. But here the given interval just 0 to pi by 2. In case if they given 0 to 2 pi, 0 to 3 pi, 0 to 4 pi, the interval at that time you have to take the general solution. So here it is not necessary that. Okay. And okay, fine. Here now, so the f dash of x, we have to check whether it is okay. Here the critical value clearly belongs to close interval 0 to pi by 2. Okay, fine. But in the question, observe the question. What is they asking? Prove that it is increasing the given interval. Increasing the given interval. So when I equating to 0, we got the critical value. Critical value clearly belongs to given interval. And also in 0 to pi by 2, we have to check whether this f dash of this f dash of theta means dy by d theta is greater than 0 or not. This total value. For that, I am going to check it. Okay. And after simplifying, when we simplify this actually, like take LCM after simplifying this here itself. After simplify this 8 cos theta plus 4 minus of by taking LCM 2 plus cos theta. Okay, whole square here 2 plus cos theta the whole square. Okay, so here 8 cos theta plus 4 minus 4 plus 4 cos theta plus cos square theta by 2 plus cos theta the whole square. For understanding purpose, I am written here. So even you may write directly also. So here 4 get cancel. 4 get cancel. Then here remaining 8 cos theta minus 4 cos theta becomes 4 cos theta minus cos square theta by 2 plus cos theta the whole square. Okay, shall I take this as the f dash of theta? So dy by d theta in the interval 0 to pi by 2. Okay, now we have to check f dash of what is the f dash of theta, students? Right, first I want to take f dash of theta. Yeah, f dash of theta after simplifying 4 cos theta minus cos square theta. When I take cos theta common, 4 minus cos theta by 2 plus cos theta the whole square. See, I have written this dy by d theta nothing but f dash of theta. After simplifying this, I may get like this. Finally, we get like this. Okay, now I'm going to check. I'm going to check in the interval 0 to close interval 0 to pi by 2 whether f dash of theta is greater than 0 or not. Greater than 0 or not. That I want to check it here. Okay, now in interval 0 to pi by 2. 0 to pi by 2. I am taking just open interval. 0 to pi by 2. Here we have, what about cos theta, students? In first quadrant, cos theta positive or negative? Just I am taking separately, like first I want to check cos theta, then after I want to check 4 minus cos theta, then after I want to check 2 plus cos theta whole square value in this interval. Yeah, tell me cos theta greater than 0 or lesser than 0 first quadrant?
Positive.
Yeah, positive, greater than 0. Also, what about 4 minus cos theta? Greater than or lesser than? What is the maximum value of cos? Plus 1. Then 4 minus, otherwise, take here. What about 4 and the cos theta relation between? Is there 4 is greater than cos theta or lesser than cos theta?
Lesser. 4 is greater than cos theta.
4 is greater than cos theta. When I take cos theta left side, which implies 4 minus cos theta is greater than 0. Am I right? Because maximum value of cos is plus 1. Okay. So cos theta 4 is always greater than 2 cos theta. 4 minus cos theta greater than 0. Okay, fine. This is also greater than 0. Denominator, whole square is there, whole square. So, and always here 2 plus cos theta always whole square is greater than 0. Overall, so numerator is greater than 0, denominator is greater than 0, which implies, okay, cos theta into 4 minus cos theta by 2 plus cos theta the whole square is overall greater than 0. This is nothing but what? F dash of theta, no? greater than 0. This is nothing but f dash of theta. So overall, so the given derivative is we got greater than 0, which implies what about f of theta more? Which implies what we can conclude? y is increasing. Increasing means strictly increasing actually here, not greater than or equal to 0. Greater than 0 here. Okay, increasing in open interval 0 to pi by 2. Okay, I checked in open interval, but the question they asked in closed interval. Closed interval. So what shall we do here? Closed interval means okay. Now what shall we do here? Now we have to write here also the given function. Whatever the given function, y is continuous at theta is equal to 0 and theta is equal to pi by 2. It is clearly continuous function. So that therefore, finally we can write therefore f of x is, or hence f of x is increasing in 0 to pi by 2. Okay, at endpoints also it is continuous, nothing but it is a finite value, not infinite. Okay, so like that we have to write. So what I have done here, I differentiated with respect to theta with help of u by v. So we got dy by d theta, that I have taken as f dash of theta. So I have to equate into 0. We got finally the critical point is pi by 2. Pi by 2 is clearly belongs to 0 to pi by 2. Okay. After that, I have written simplest form, that f dash of theta. Simplest form is f dash of theta is equal to cos theta into 4 minus cos theta by 2 plus cos theta whole square. Cos theta greater than 0, 4 minus cos theta greater than 0, denominator already greater than 0. With help of this, total value is greater than 0, which implies f dash of theta also greater than 0. Whenever it is greater than 0, it is increasing. So it is also continuous at endpoints. Then finally it is increasing in the given interval. Okay, next, logarithmic function. Logarithmic function, prove that the logarithmic function increasing on 0 to pi by 2. See, graphically we know that f of x is increasing function always. This is 1 comma 0. So the graph is like this. This is the graph. So they are asking at 0 to infinity, but open interval, see here, open interval, because we cannot take close interval 0, log 0 is undefined. So that open interval. So from 0 to x is equal to 0 to infinite, it is always increasing function. Okay, always increasing function. Let's see here. F of x is equal to log x. F dash of x is equal to already 1 by x. 1 by x is not defined close interval 0 to infinity, because when I substitute 0 here, it will be 1 by 0 infinity. So that they given the interval is open interval 0 to infinity. So open interval 0 to infinity, f dash of x always existed. Yes or no? At 0 alone it is undefined. Other than 0 from minus infinity to plus infinity, it is always, yes, it is always continuous, exist, defined. The value is defined. Okay, students. So right. So when I equate into 0 here, it is always greater than 0. X belongs to this interval. So f dash of x is greater than 0 for every x belongs to open into 0 to infinity. Is it greater than 0 or not? See here, in this interval, take x value 0 to infinity. Yes, students. Did you get my point here?
Yes, sir.
Yeah. So clearly in the top, because 0 to infinity means it is positive, 1 by x is greater than nothing, but it is increasing. We proved here. That's all. Hence f of x is equal to log x is increasing in the interval 0 to pi, but that we have to write it. Okay. Now, the next one is question number 11. This is okay. So prove that the function is given by f of x is equal to x square minus x plus 1, neither strictly increasing nor decreasing on minus 1 to 1. So same procedure, take the given function. See, again, prove that given so that interval is given. Right, now. Question number 11.
So 1 minute, can I scroll up to?
Yeah. Roughly have done this. This I am giving as homework, a simple question.
Thank you, sir.
Yeah. Okay, students. So what is the question? Given function is what? Question number 11. F of x is equal to? Yes. X square
Minus x plus 1.
minus x plus 1. Interval?
Minus 1 to plus 1.
Okay, right. See, same procedure. First, what we have to do? F dash. F dash of x here. First, stop writing. Just look at here. I can explain within 1 or 2 steps the answer. Okay, first one is calculate f dash of x. Then after, to find the critical values, this f dash of x equating to 0. So f dash of x means 2x minus 1 is equating to 0, which implies we are going to get x value. X value is 1 by 2. Got it? Okay, this is the critical point. So given line from where to where here? Interval minus 1 to 1. So minus 1 to 1. In that, clearly the critical point is belongs to the given interval. This is clearly belongs to given interval minus 1 comma 1. Okay. So just we have to check f dash of x is whether greater than 0 or lesser than 0 in the given subintervals. Okay, here we are having 2 intervals. Okay, what are the 2 intervals? Here, interval sine of f dash of x, then nature of f of x, that is increasing or decreasing. So what are the intervals, students? What are the intervals? We got it here. We can minus 1 to 1 by 2. We cannot take minus infinity to minus 1. Don't take, because already they given particular interval in the question, because it is a proved question. So they already given. So we should not take minus infinity to minus 1. Simply you can take minus 1 to 1 by 2, 1 by 2 to 1. That's all. So another one is 1 by 2 to 1. Okay. Then what about this f dash of x value? F dash of x value minus 1 to 1 by 2. Anyone? Minus 1 to 1 by 2, 0 also there. 0 is there. Yeah, you have 0. Substitute 0, that's all. Lesser than. Okay, lesser than 0. Nothing but decreasing. Next. 1 by 2 to 1.
Greater.
Greater than 0 means increasing. Okay, increasing. So what do you observe? What do you observe from minus 1 to 1? Entire here to here?
Increasing.
Yes. So decreasing First decreasing here. -1 to 1/2, it is decreasing. Yeah, decreasing. Then 1/2 to increasing. Increasing. So decreasing, decreasing, increasing. Nothing but what we can conclude? Whenever decreasing, increasing. Yes, neither. Yes, same you can write. Same you can write. So clearly given function is decreasing from -1 to 1/2 and increasing from 1/2 to 1. Hence the given function is neither strictly decreasing nor increasing nor decreasing -1 to 1. That's all. You have to write directly. Steps and all, clearly. F of x is strictly decreasing in -1 to 1/2 and strictly increasing in 1/2 to 1. Hence, what shall we write finally? F of x is neither strictly increasing nor strictly decreasing. That's all. In -1 to 1. Like that we can write only 2 or 3 steps. But you have to write here clearly the given function is and the given interval is. Then after differentiate, let us take this is equation 1. Differentiate 1 with respect to x. So after that, we have to equating to 0 f dash x. Like that, those steps and all you have to write it. I hope so. That is very, yeah.
So the last part, sir.
Students, if you're not understood any step here, you can ask. So if you understood very clearly this increasing, decreasing concept, maximum, minimum becomes easy. Okay, in maximum, minimum, we are going to use first derivative test and the second derivative test. With help of that, we can get the maximum value of a function, minimum value of a function. Okay. And one more thing, students, then for this OBT5, we have the +1 concept, parabola and ellipse. What about that? Yes. Shall we take evening classes 5 to 6? Or else there is another way. Shall I record that each and every problem by Zoom or else Google Classroom? Can I post in your classroom? It's up to you. Like I'm ready to take 5 to 6.
Classes.
Yes.
So you can record and post.
If you want to, I can record 1 hour or 2 hours. I'll take continuously. I'll write the solution with explanation properly. I'll be post. So whenever you're having time, you can proceed that. Because not yet I started, because after asking you only, I'll be start. Yes, Kishore? So the portion is week 9, week 10, I think. Am I right? As well as plus 1 concept, ellipse and parabola. Okay, ma. I'll be decide and I'll tell you. It's better to, I think, recording. Second year concept I'll be continuing. In this regular classes, I'll be continue that class 12th portion. Then evening time and all we'll take that. Okay, coming to the next question. Okay, which of the following functions are decreasing? Decreasing, let us check. We can do directly also. Okay, 0 to pi by 2. Question number 12. Okay, first subdivision. What is the function of cos x? What is the interval? 0 to pi by 2. Okay, with help of graphical representation, what about cos increasing or decreasing from 0 to pi by 2? Yes, cos 0,
Increasing.
1, pi by 2, decrease. Yeah, we can say directly it is decreasing, but we can't write directly, no. So that what shall we do? Same, f dash of x minus sin x. Okay, what about f dash of x? Is it greater than 0 or lesser than 0? First, we know that sin x is greater than 0. X is belongs to 0 to pi by 2. Am I right, students? In first quadrant, sin is greater than 0. Which implies when sin x is greater than 0, what about minus sin x? When I multiply with minus, lesser than 0. Okay, I am taking here open interval so that strictly greater than. If it is closed interval, greater than or equal to 0, because at 0, sin 0 is 0. Okay, anyhow, sin x is greater than 0, minus sin x is lesser than 0, minus sin x nothing but f dash of x. F dash of x lesser than 0. So, which implies what can we conclude? F of x is increasing or decreasing? Decreasing.
Decreasing.
Yeah, decreasing in 0 to pi by 2. Okay, first subdivision is decreasing. Second, cos 2x is there. First one, is that clear? I differentiated. We know that sin x is greater than 0, minus sin x is lesser than 0. Minus sin x means f dash of x. Second one also, second subdivision of same cos alone, but here cos 2x. Now, see students, find f dash of x minus 2 sin 2x. Am I right? Students, clear? Okay. See, what is the given interval, Amma? X is belongs to what is the given interval? 0 to pi by 2. Here given interval decreasing, nothing but x is belongs to 0 to pi by 2. But see here we having 2x. X is belongs to 0 to pi by 2 means x belongs to 0 to pi by 2 nothing but 0 is lesser than x is lesser than pi by 2 will write because open interval. But here we are having the angle is 2x. 2x. So multiply with 2. 0 lesser than 2x is lesser than pi. Pi. Am I right? Okay.
Yes, sir.
Then what about sin 2x and 0 to sin 2x? Sin 2x means sin 2x from first quadrant. 0 to pi means first and second quadrant. First and second quadrant sin is positive or not? Positive. So what shall we write here? Since sin 2x is positive in 0 to pi. Okay, so here if you take sine 2x, nothing but we are getting positive value alone. Okay, so whenever sine 2x is positive, 2 sine 2x positive, nothing but greater than 0. 2 sine 2x also greater than 0. Then when I take minus,
Decreasing function.
yeah, lesser than 0. It is nothing but f dash of x again. F dash of x is for every x belongs to 0 to pi by 2. Okay, nothing but decreasing. Again, so it is also decreasing. Okay, then what about the next one? Is it clear? Once you can check it here, what I would have. Getting any doubts, you can ask.
What else?
Okay, you have to write clearly. Therefore, f of x is strictly decreasing in 0 to pi by 2, like that you have to write. Third subdivision. Yeah, otherwise you can try this third subdivision and fourth subdivision. Next class, I'm going to finish this increasing decreasing concept. You can try the remaining questions. Some all questions are easy. For example, on which of the following intervals the function which is given by decreasing. So you have to take this interval, you have to check f dash of x. F dash of x is 100 x power 99 plus cos x. That's all. That's all. See 0 to 1. 0 to 1 cos x is clear. 100 x power 99 is positive. Cos x also positive. Overall, it is greater than 0. It is not. It is clearly increasing, but they are asking decreasing. It is increasing. So first interval, it is not decreasing. Second interval, pi by 2 to pi. At the second quadrant cos is negative actually. This is negative, but pi by 2 to pi, this is a numerical value. No, what is pi by 2 value? Pi value 3.14. Pi by 2 is some value, 1 point something will get. 100 into 1 point something means it is almost like a 60, 70 value, like that. Well, but cos maximum value plus 1. Cos is lesser than 0, maybe negative value 0 to minus 1. But here 100 into 1 point something. So in that case also we are going to get f dash of x is greater than 0. Then 0 to pi by 2, already both will be, it is greater than 0. This is also greater than 0. Greater than 0. So greater than 0 means increasing. First subdivision increasing, second subdivision increasing, third subdivision increasing. So fourth one alone correct. Fourth one alone correct. None of these interval, it is decreasing. Like that, simple. Here also f dash of x equating to 0. From that you are going to get a value. Here already they are asking prove that the given function is increasing. Already they are given increasing, they are given even interval also. Just find f dash of x and you have to check in that interval it is increasing or not. Second 16th question also you have to derivative. Here also you can differentiate. Every question you have to differentiate. Okay, try yourself. Shall we wind
Thank
up
you,
the
sir.
class, students?
Thank you, sir.
Okay, ma.